What if I told you that the AI models we're all working so hard to train are actually already a lot smarter than we think? Well, we're about to dive into some really fascinating new research that suggests exactly that.
The big question on everyone's mind in AI right now is this one. How do we get these models to go beyond just pattern matching and actually reason through tough problems, like solving complex math or writing really solid code?
For a long time, the field has had a kind of go-to answer for this, a reigning champion for making AI smarter. And that champion is reinforcement learning, or RL. The whole idea is pretty intuitive, right? You give the AI a problem, it gives you an answer, and if it's right, you give it a little reward. You do that millions of times, and boom, it gets better. And look, it's led to some incredible breakthroughs. But this champion has a pretty steep price tag. Yeah, the hidden cost of RL is actually huge. You need these massive, carefully curated data sets. The training itself is incredibly expensive and complex, and honestly, it can be super unstable and a real pain to tune. Plus, you always need that verifier to hand out the rewards, which isn't always practical. And maybe the biggest downside, it tends to make the AI kind of rigid. It learns one good way to answer and sticks to it, killing the diversity of its responses. So, all of these costs and problems led some researchers to take a step back and ask a really, really fundamental question, one that kind of flips the whole problem on its head. They basically asked, hey, is all this expensive RL training actually teaching the AI something new? Or is it just unlocking abilities that were already there, just lying dormant inside the original model? I mean, think about that for a second. That's a huge shift in how we think about this. Let's put it another way. What if the problem isn't the AI model at all? What if the raw, base model already has these incredible reasoning skills, and we've just been bad at asking for them? What if there's a better way to coax those skills out, right at the moment we need them, without any of that expensive retraining?
And that question leads us directly to the brilliant solution they came up with in this paper, a whole new technique called power sampling. Okay, to really get why this is so cool, you have to see how different it is from the standard way of doing things. The typical method, what's often called greedy sampling, is like just blurting out the first thing that comes to your mind. The AI picks the next word that looks good in the moment, but that can easily lead it down a totally wrong path. Power sampling, on the other hand, is more like a chess master. It doesn't just think about the next move, it thinks about the entire game. It considers the whole line of reasoning from start to finish and picks the one that is the most logical and coherent overall. Now, the secret sauce behind this is a mathematical concept called the power distribution. But don't worry, you don't need a PhD to get it. It's basically just a way of sharpening the AI's focus. It's like telling the model, look, out of all the possible answers you could give, I want you to ignore the noise and focus only on your most confident, most complete, most logical lines of thought. It really hones in on the best knowledge the model already has. So how does it actually work? Well, it's this really elegant, iterative process. First, the model just spits out a complete first draft answer. Then, it randomly picks a little piece of that answer and tries rewriting just that part. Now, here's the magic trick. It looks at the entire answer again and asks itself, did that little edit make the whole thing make more sense? If the answer is yes, it keeps the change. If not, it throws it away. And it just does this over and over and over again, constantly refining the answer until it lands on something that's super coherent and logically sound. All right, the theory sounds great, but, does it actually work in the real world? This is where things get really, really interesting. Let's look at the results. So check this out. On a really tough math benchmark, the base model gets it right about half the time. The super expensive RL trained model, it gets a very impressive 78.5%. But now look at power sampling. With zero, and I mean zero, retraining, just by being smarter at inference time, it hits 74.8%. It's nearly matching the heavyweight champion without ever stepping into the training gem. But wait, it gets even better than that. Remember, the RL model was specifically trained to be good at math. When you throw these models a curveball, a task they weren't trained on, like a complex coding problem, power sampling doesn't just keep up, it actually outperforms the RL-trained model. It's just more flexible, more of a general problem solver. And remember that diversity problem we talked about? This solves it. This chart basically shows what happens when you give the model a few tries to get the answer right. The RL model, that blue line, it finds one good answer and then just kind of flattens out. But look at power sampling. That line just keeps on climbing.
What that tells us is that it's not just finding one right answer. It's finding multiple, different, correct ways to solve the problem. It's not just smart, it's creative.
So when you put it all together, what you have here is the best of both worlds. You're getting that super high-level performance that we thought you could only get from expensive training, but you're also getting the creative flexibility and diversity of the original model. It's a huge win-win.
So this is more than just a neat little trick. The implications of this discovery are actually enormous for how we think about building AI in the future. Let's just break down the big takeaway here. You get top-tier reasoning without any expensive retraining. You don't need special datasets. You don't need an external verifier. Why? Because you're just unlocking the amazing potential that's already inside the model. And this points to a whole new way to make AI better. Instead of just throwing more training data at the problem, we can scale by using a bit more compute at the moment we ask the question.
The authors of the paper really said it best themselves. The models we already have are so much more capable than our current methods have been able to show. We've been leaving all this incredible performance just sitting on the table.
And that really just leaves us with one final mind-bending question. If a single clever new way of asking questions can unlock this much reasoning power that was hiding in plain sight, what other incredible abilities are still waiting in there to be discovered? What's the next thing we're going to unlock?